For our final question on our practice test, we're dealing with a modeling problem, really like a physics problem. A rock is thrown upward with an initial speed of 64 feet per second. This is what we call our initial velocity, that's v sub 0, v naught. From a cliff 50 feet above the ocean, that's your beginning height called h naught. After how many seconds since the rock is thrown will it hit the beach below? Well, you're going to thankfully be given a formula that you see right here. The height is negative 16t squared when you're measuring distance in feet, plus your v naught, that's your 64. We'll have 64t, and your beginning height is 50 actually, so you could put 50 in for h naught. And right now you have a formula that would describe the height of the rock for any given time, as long as this model is correctly modeling the situation. So you could plug in t equals 1, for example, and you can find the height of the rock 1 second after this person throws it upward. What we'd like to know, though, is when will the rock hit the beach below? The beach below is going to have a height of 0. So when the rock hits the ground, your height is going to be 0. And this means you're going to solve this equation for time. Now, what you want to do, again, is make use of your calculator. You want to store your A, B, and C. So our A is going to be negative 16. Our B is 64. Our C is going to be 50. And it won't take you too long to get this typed in. We'll type in negative 16, store that in for alpha A. Type in 64, store that for alpha B. Finally, do 50, store, and hit alpha C. Now, in its own way, this problem actually gets easier than the ones we had done just on the previous page. On the previous page, we'd solve with the quadratic formula, but we'd only originally type in the b squared minus 4ac right inside this radical right here, and then we'd break everything down with the radical, and we'd separate having two fractions, perhaps adding and subtracting them together. Here, though, we don't want to have fractional answers. We'd much rather come up with a decimal answer. So tell you what, we're going to make a fraction appear, go alpha y equals, so we can type out the quadratic formula. So make your fraction alpha y equals, type in opposite alpha b. I'll start with the plus, then we'll say second x squared to get the square root. I'll say alpha b squared minus 4 alpha a alpha c. Bring this down here to get 2 alpha a. And in all honesty, that's one of the solutions to this problem. You hit enter and you get something very strange. Negative 0.7 seconds, really. Now imagine how strange that would be to say, yes, the rock is going to hit the ground negative 0.7 seconds after this person threw it. This model wouldn't make sense for negative time. We're going to assume that t equals 0 is when this model begins to describe the height of that rock. What's going on? Well, you get two answers from the quadratic formula. One of them you're going to see in this regard won't be making much sense. Notice that we had negative b plus the square root of b squared minus 4ac. I'd like to do negative b minus. So tell you what, let's hit second enter. Second enter will toggle back to what you had just typed, and then you can hit the left arrow, back arrow, to go over the plus sign and replace it with a minus sign. You don't have to right arrow all the way to the end of the problem. You could just hit enter right now. But you could see 4.7 is what we're going to have. But please hear this, to get full credit, you need to write a sentence. You can say, the rock will hit the beach after 4.7 seconds, or at 4.7 seconds. And that's all you have to do.